Hello everyone. I just wanted to make a video for you to help you with the last few examples that we didn't get to in class in Module 3. Because we started with logs in class, I just think logs are a little simpler for our brain to deal with. So that's why I started with it in class, and that's why I'm going to start with the logs today in this video as well. Okay, so I'm going to work number 4 here. I mentioned this briefly in class. This doesn't really fall into one of our cases here in our process. This is kind of an oddball. The reason that this is different is because our variable x that we're trying to solve for is already in an exponent inside a log. See how all of these other ones, they were just in the bottom inside of a log, right? Like they were just not in an exponent. They were just there, like, right? They were polynomials, is what I mean by that. So this one's a little different because I don't have just an x or numbers inside the log. My variable is in an exponent. So because this whole thing is inside the log, my x minus 4 is a power inside a log. Because we have a power inside a log, we can use our properties of logarithms, which we did the other day. And right here, this power rule, you can, if you have a power inside a log, you can drop it out front like a coefficient. So that's where we're going to start this one. So we're going to take that x minus 4. I'm going to switch colors here. So we're going to take this x minus 4, that's our power inside the log, and we're going to put it out front of the log like a coefficient. So let's do that. And when we do, we're going to have x minus 4 times log base 1/5 of 19 equals 20. And 19 is the only thing left inside that log now. Now, this looks a little funny, but I want to point out here that this log base 1/5 of 19, this is just a number. You could use your change of base formula. You could put it in your calculator. It's just a number. So to make life easier for ourselves, um, it's just a number being multiplied by something with x's in it. We can go ahead and divide it off because, to be honest with you, we're trying to get to x, which is over here. That thing is freaking me out. We can just divide both sides by it because it's just a number. So when we divide both sides by log base 1/5 of 19, I have just x minus 4 left on this side, and on the other side, I have 20 divided by log base 1/5 of 19. And now to get to x, you just add 4 to both sides, and we get 20 over that lovely log base 1/5 of 19 plus 4. So that's what x is. Now, the hard bit about this is going to be putting this in a calculator, because log base 1/5 of 19, you don't have a calculator button for log base 1/5. We have to do a change of base on this. So we're going to have 20 divided by, to do the log base 1/5 of 19, you can use either the log base 10 or log base e. I think most of you like to use log base 10, so I'll stick with that. And so we're going to do log base 10 on the top and bottom here. The thing inside your log, which is our 19, goes on top. Your base, which is 1/5, goes on the bottom. Again, base on the bottom. And so this is how we're going to put this in our calculator. Now, this is our big division bar. You need to figure out how to tell your calculator that log of 19 divided by log of 1/5 is all in the bottom of this fraction. So you actually need to put parentheses around that to make sure that your calculator does order of operations correctly. So if I were plugging this into my calculator, I would type in the 20 and then divided by, and then I would start my parentheses for this guy, and I would do log of 19, that's the top bit, divided by the log of 1/5. So 1 divided by 5 gives you that 1/5. And then I need this set of parentheses here after the log of 1/5 to say that's the last thing on the bottom, right? So that parenthesis ends this one. Those are my big parentheses here. and then we're going to add 4 to that. So these are kind of the calculator strokes that you would use to put this in your calculator. Be careful with those big parentheses there, but you have to make sure that you put parentheses around it to tell your calculator that all of that is on the bottom. And so when I put all of this into my calculator, I'm going to get, let's see, I did this just a minute ago. When I put that in my calculator, I got negative 6.932. And this might tingle your spidey sense a little bit because today when we were checking our solutions, we had to make sure that our solutions didn't make a negative inside a logarithm, right? So you might say, ooh, negative, that makes me a little nervous. But notice when we put it into our formula in here, like if we put it into our equation to see if it works, we're going to take 19 to the negative 6.9 minus 4 power. It's 19 to a negative power. That means 1 over 19 to a positive power. It means a small positive number. And so I have a small positive number inside my log. So here, let me write this out in case that didn't make sense, and because technically we need to check this. And I'm sorry, I'm trying to squeeze all of this in here, and it's tough to do so. So I'm going to do my check for this piece, and we have to make sure that when we do log of 1/5 times 19 to the negative 6.932 minus 4 power, we don't get a negative in here, right? Everything inside our log has to be positive. So when I do log of 1/5, in here I get 19 to the negative 10.932. You can put that in your calculator. If you are feeling like, I don't really know if that's positive or negative, then put 19 to the negative 10.932 power, and you'll notice it tells you it's 1.048 times 10 to the negative 14th. 1.048, I'm going to round it there, times 10 to the negative 14th. This 10 to the negative 14th, what that means is that you need to move your decimal place 14 places to the left. It's a tiny number, but it's a positive number. Again, I'm sorry for there's like no space in here. This means it's going to be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros, and then that 1048. That's what this means. It means you're taking this decimal place and moving it to the left 14 places. So this is the number that we're talking about. It's positive, but it is so teeny tiny, but it's still positive. So that means that we're good and that this solution works. So yeah, with these, just these kind of logs, because that negative is in an exponent here, we're going to be good because the range of exponential functions is positive. So we're going to be good with these kind of functions. I just wanted to kind of go through that with you. Okay, so big thing here, you're going to drop your exponent down. This is just a number. Treat it like just a number. Divide it over. Add the number attached to that x, that +4, and then be careful when you're putting that in your calculator. And again, we usually check these. These will always work because our x is in an exponent of an exponential, and we didn't have any domain issues with those. That's kind of the short part of the story there. Okay, and then the last two that I wanted to do are the two exponentials that we didn't get to, which are 3 and 4 here. Okay, so 3, 14 to the x plus 7 equals 17 to the 4x. Can we write both sides as powers of the same base? Can I write 14 as a number to a power and 17 as that same number to a power? No, we're not going to get anything nice here. 14 isn't a power of anything except 14, and 17 is not a power of anything except 17. So we're not going to be able to write these with the same base. So we are in case 2 here. Now, I know it says isolate the expression if possible, right? You want to get a number to a power by itself on one side and a number on the other side. If you can't do that, I want you to put one exponential on each side of the equation. And so it'll look like your base to an m power times another base to a different power, right? So you'll have one exponential on either side. And that's the case that we're in right here. We've got a base to a power on one side equaling another base to a different power on the other side. We already look like this. Now, if you put one on either side, the rest of the steps don't change. You still need to take the log of both sides. We need to introduce a logarithm here to bail us out. And we're going to apply properties of logs after we take the log of both sides. So we need to introduce a log here. You can use log base e, that's the ln, or log base 10. Any log base will work here. So I'm going to use base 10 because I think that's where most people are the most comfortable. So I'm going to take log base 10 of both sides. It's kind of like taking the square root of both sides. You're just going to apply that log function to both sides. Okay. And again, if your brain doesn't like not having a base, you can write the base 10. Or if your brain doesn't want any extra stuff, you don't need to write the 10. Do what your brain likes. Okay, so we took the log of both sides. Now notice the base of the log and the base of the exponential don't match for either of these, so we aren't going to be able to just simplify these right off the bat. But what we can do is now that we have a log in here, I've got powers inside these logs. So what I can do is take the exponents and drop them out front just like we did in the last problem. So when I take the x plus 7 down, I'm going to have the entire x plus 7 times log of 14. Again, if you want to write the base of 10, write the base of 10. And then I'm going to move this 4x down, and I'm going to have 4x times the log of 17. Okay, so I've got this. I need to solve for x, right? I'm trying to get x by itself. The problem here is that I've got an x on this side and I've got an x on this side. Your goal here is to put anything with an x on one side and anything without an x on the other. But I can't move anything over here around because that x is stuck inside these parentheses. So before I can start moving stuff around, I need to distribute this log of 14. That might feel a little funny, but log of 14 is just a number. If this had been the quantity x plus 7 times just 14, you would be okay with distributing out that 14. Log of 14 is still just a number, so we can work with it just like we would any other number. So when I distribute this out, I'm going to have x times the log of 14 plus 7 times the log of 14. On the other side, I still have this 4x times the log of 17 hanging out. Now that I've distributed, everything here can be moved around a little bit better. I want to put anything with an x on one side, anything without an x on the other. I have an x here and I have an x here. I want to put those both on the same side, and anything without an x I want to keep on the other side. So I'm just going to move this x log 14. I'm going to subtract that from both sides to move it over. That way I don't have to move two things. So I'm just going to move that over. When I do that, I'm going to have 7 times the log of 14 left over here. And on the other side, I'm going to have 4x times the log of 17 minus x times the log of 14. Might look like we're not really getting anywhere, but now I have everything on the right side of this equal sign has an x in it. That's what I want to solve for. So I'm going to factor it out of everything on this side. When I pull an x out of everything on this side, I get 4 times the log of 17 minus the log of 14, right? I can factor that x out just like we would factor anything else out. And since I'm trying to get x by itself, notice everything in parentheses is just a number. 4 times log of 17, that's a number you could put in your calculator. Log of 14, that's just a number. When I subtract two numbers, I get a number. This is a number times x. So how do we get x by itself? We divide both sides by that number. We divided that side, we got to divide this side as well. 4 times the log of 17 minus the log of 14. When we do that, these guys, oops, there we go. Let's try that again. These guys cancel, and I'm just left with x over here. And so x is equal to 7 times the log of 14 divided by 4 times the log of 17 minus the log of 14, right? All of this equals x. But I want to put that in my calculator. That way I can get a number out. When you put this in your calculator, because we have multiple things, right? We've got multiplication on top, we've got a subtraction on the bottom. I want you to put parentheses around the top and parentheses around the bottom when you're putting this into your calculator. So when you do that, you should get, again, I put this on my calculator to make sure that you do that properly. When you put that in your calculator, check, you should get 2.125 out when you put that in your calculator. Put parentheses around the numerator and parentheses around the denominator. Cool. All right, so that's how we work problems like that. I know it doesn't feel like case 2 because you have two exponentials, but just put one exponential on each side and then take the log of both sides. And then once you take the log of both sides, use your properties to move your exponents down, put anything with a variable on one side, anything without it on the other, so that you can factor your variable out and divide all of that other garbage off. Okay, so now number 4. This one is completely different than any of the other ones that we've seen. Again, this is a good challenge problem. So it's a good one to kind of get your brain started to apply factoring rules to something that looks a little bit different, because we're going to be doing that later in the semester with trig functions as well when we get into trigonometry. So we're going to start this process with our brains now with exponentials. I'll tell you right now, I'm not going to make you do this on your test on Monday, but like I said, we're going to be doing this later in the semester. So this is a good challenge problem on your homework to start your brain getting in the habit of looking at the structure of problems rather than exactly what's in it. Okay, so we want to solve e to the 2x minus 11 times e to the x plus 28 equals 0. This is kind of strange. Something that I want to point out that might not be readily obvious. E to the 2x. That's the same as e to the x squared. Because again, if you've got powers, two powers, you're going to multiply them. So e to the x to the second power is e to the x times 2. That's e to the 2x power. So this means e to the 2x. I just wrote it a little differently, and I'm going to leave everything else the same. And notice, when we write it like this looks an awful lot like a quadratic function, right? Like this looks a lot like x squared minus 11 times x plus 28 equals 0. These two have the same structure, but instead of x, I have an e to the x, right? So what we're going to do is we're going to factor this. If your brain can't factor this with the e to the x's in it right now, then I want you to replace those e to the x with an x. We'll factor this, and then before we finish the problem, we're going to put those e to the x's back in. Okay, so if this was x squared minus 11x plus 28, we would have to factor this to solve it. Now, to factor it, we would need magic numbers. We would need two numbers that multiplied a times C, which is 1 times 28. That's a positive 28. And those same two numbers we need to add to our B value, which is negative 11. Do we have magic numbers that multiply to a positive 28, but add to negative 11? Yes, we do, right? 4 and 7 multiply to 28. But to get a positive 28 out of the multiplication, but a negative out of the addition, they both need to be negative. So this is going to be negative 4 and negative 7. So this, because our leading coefficient is 1 here, this would factor into x minus 4 times x minus 7, right? But remember, our original problem didn't have just x's, right? It had e to the x instead of x. So now that we have this factored, right, with the structure of the problem, we're going to come back to our original variables, and I'm going to put the e to the x's back in. So our original problem factors into this. If you're not 100% sure about that, I want you to FOIL out what we have here. If you do the FOILing and combine your middle terms, you're going to notice you end up right back where we started. So this is, in fact, factored correctly. And so now we can still use the zero property principle to say, I've got two things multiplying to 0. One of them has to be 0. So either e to the x minus 4 equals 0, or e to the x minus 7 equals 0. If e to the x minus 4 is 0, that means e to the x equals 4. If e to the x equals 4, to solve that, that's an exponential equation. And we are in case 2, right? We've got a base to a power equaling a number, so we have to take the log of both sides. I'm going to choose the natural log, right? Log base e of both sides. The natural log is log base e. So the left side here says e to what power gives me e to the x. The answer is e to the x power gives me e to the x. And on the other side, I have the ln of 4. So that means from this left side, x is the natural log of 4. Or on this right side, that means if e to the x minus 7 is 0, that means e to the x equals 7. Again, we're going to take the ln of both sides. And the ln of e to the x is just x because the bases are the same here. They cancel out. You're just left with x. And we have the x is the natural log of 7. So that's how we solve those guys. Again, I want you to start training your brain to see that the structure of this is just like a normal quadratic. We just have e to the x instead of x. But the process of factoring remains the same, and then setting each factor equal to 0. And then when you're solving each factor equal to 0, you have to solve a little baby exponential equation. So you're going to have to take the log of both sides in order to do that. All right. I hope that helps with the last few topics in Module 3 homework for Alex. Try to get through these as quickly as you can early this weekend so that you can spend some time letting your brain process everything, putting everything in your long-term memory, and then practice the test study guide problems to help you get ready for Monday. Let me know if you have any questions as you do that. Happy studying, and I will see you for test 1 on Monday.